So we're going to talk about sequences today. And a sequence is a set of elements or members. And in this class, each of those elements is going to be a number. You should have already looked at some examples of sequences on the Math is Fun website. And if you read through that, you should have realized that an important requirement of a sequence is that there's a rule that determines which numbers are members of the sequence. And this section talks about the two different ways that we have to define sequences, explicitly and recursively. So let's start by just writing some elements of a sequence here, and it's going to be a very simple sequence, 3, 5, 7, 9, dot, dot, dot. And each of these numbers in my sequence is called an element. And this dot, dot, dot over here has a very specific meaning as well, which is what? It means that the sequence goes on forever, or it is an infinite sequence. Now, what would a rule be that would help us to define the elements of this sequence? If you remember this sequence from the Math is Fun website, then you would remember that AN, and AN is my general term. It's an equation that I can use to define any other term in my sequence, and it's going to be 2n plus 1 for n greater than or equal to 1. And let's just try to calculate the first couple of elements or terms of my sequence and see if this formula is right. So A1 just means that wherever I had an n, I substitute in a 1. So 2 plus 1 is 3. And lo and behold, that is the first term of my sequence. And if we do the second term, A2, I'm just going to substitute in 2 for n, and I get 5, which is again the next term in my sequence. So if we were going to write the sequence in general, I might say that I have an A1 term, an A2 term, an A3 term, and then if it was an infinite series, I would have my dot, dot, dot. Now this is an example of an explicitly defined sequence. And it's explicit because I can calculate any random term that I want without knowing any other element in the sequence just by looking at this general formula here. So if, for instance, I wanted to figure out what the 205th term of my sequence is, I just go to my general formula over here and I substitute in 205 anywhere that I see an n. And if you can do your math quickly enough, we're going to end up with 411. Now, another way to define a sequence is recursively. And here, I need to know at least one of the other elements in the sequence, because the formula for my nth term, my general formula, is going to be defined in terms of some other element in the series. So if we talk about recursive, let's say that my series is going to be an, my general term will be an, 3 is equal to 3 times a, n minus 1. Well, if I want to figure out what the second term in my series is, then I substitute in n equals 2, and that's going to be equal to 3 times the a1 term. But I need to know what that a1 term is. So for instance, you'll be told that maybe a1 is equal to 1, in which case my a2 term will be equal to 3. And then I can go ahead and write the elements in this sequence by knowing the element before. Of course, if A1 was equal to 5 or 10 or 27 or 99, I'm going to get different elements in my sequence. Now in the next section, we'll be talking about the geometric and the arithmetic sequences, and both of these are defined recursively.